Hey everyone, these are the area, surface area, and volume guided notes. To get started, let's go over some vocabulary. Perimeter is the distance around the edge of a figure. The units used would be units because we are measuring a distance. Area is the number of square units that can be contained in a 2D figure. The units used would be units squared or square units because we're talking about how many squares cover inside a 2D figure. Surface area is the sum of the areas of the faces of a 3D shape. The units would be square units or units squared. Volume is the amount of cube units that can be contained inside a 3D shape. The units would be cube units or units cubed because we're talking about how many cubes can fit inside the 3D shape. Let's move on to composite figures. Many figures are composites of parallelograms and triangles. So that means that the figure is made up of parallelograms and triangles. Let's analyze the following figures and divide them into parallelograms and triangles. Now I'm going to do it one way, but this is not the only way to do it. There are different ways that you could divide these up. So if I'm looking at this first shape here on the left, I can divide this right here and right there, and I could also divide this right here. So that gives me these rectangles right here, and then it also gives me this triangle. Let's now divide up this hexagon here on the right. I can go like this right here, and that gives me a rectangle or possible square here in the middle, and then these two triangles here on the side. Create your own composite figure below. Divide your figure into parallelograms and triangles. Okay, so you can make up your own shape that is composed of parallelograms and triangles. I'm just going to do a simple house. And I can divide it right here. And that gives me a triangle here up on top. And then this square on the bottom, or rectangle. The reason why it's good to divide them up is that when we get into composite shapes, then we can divide them up and it's going to be easier to calculate the area. So we have this shape here on the left. Now this is the same one we had up top. Let's divide it up just like we did before. We're going to have right here and right here. Now we're going to calculate the area of the different sections and then sum them together to get the total area. So let's first look at this section right here. This is a rectangle, and so I have my base times my height, which is 12, and that's the area of that section. Going over here to the left, my base times my height. Well, I know my height is 6. I don't know my base right off the bat, which would be this right here at the bottom. But let's see how I can figure that out. I know that this here is 9, and I know that this is 6. Therefore, this section right here, or this section right here, is going to have to be 3, because 9 minus 6 is 3. Now, to figure out the area of that section, I'm going to be going 6 times 3 equals 18. Let's move on to the next rectangle, which is right here. So again, I need my base, which will be 6. And my height, again, I don't know my height right off the bat, but I know this is 6. And I know this is 2. Coming over here, this is 2. So in order to get 6, this must be 2 as well. So I'm going to have 6 times 2 equals 12. And then my triangle over here, it's going to be base times height divided by 2. I already know that this is 2. I don't know what this section right here is, but I know this whole thing is 15. And I know from here to here is 9 because from there to there is 9 and it's the same distance. So 15 minus 9 will give me 6. And so I can go 6 times 2 divided by 2 because it's a triangle, and that's going to give me 6. Now I'm going to sum those all up to get my total area, and that's going to give me 48 centimeters squared. Moving on to this figure here on the right, I'm going to divide it like I did up on the top. So I'm going to have this triangle, and I know that in the middle is actually a square because this is 4 and this is 4. So the base times the height is 16. So we're going to write 16. And I'm going to do the sides, which they are the same, right? This is going to be the same as this. So now we'll do base times height divided by 2. So, and it's a perpendicular height. So if I look at my triangle, here's my base, here's my height, and then divided by 2, which equals 2. And I also have another one of those right here. So that's 2 as well. Or if I put those together, I could have a parallelogram and find out the area of that. So if I sum those up, I'm going to get 20. So that is the area of this composite figure above. Let's move on to 3D shapes, prisms versus pyramids. Many 3D shapes can be classified as prisms or pyramids. Prisms have 2 bases, whereas pyramids have 1 base with an opposite point called apex. Classify the following as prisms or pyramids and write the shapes of their bases. Okay, so with prisms, the bases are going to be the 2 faces that are parallel to each other and the same. So if we look at this shape right here, notice that this face and this face right here are the same and they are parallel to each other. So that is a prism. And then those 2 faces that are parallel to each other are the base. And so my base shape would be a triangle. Moving on to the top middle. If you notice I have this point here at the top, that's called the apex. And this face, which is opposite that point, is called your base. So first of all, this is a pyramid. And the shape of that pyramid is a rectangle. Or actually in this case, it looks like a square. But both would be correct. I think it is a square. We can say square or rectangle. All right, let's look at the top right one. So again, if you notice, I have 2 faces that are the same and that they are parallel to each other. That makes this the bases, and this is a prism. And the shape of those bases, it has 6 sides, so that's going to be a hexagon. On to the bottom left, notice I have my apex here again, this point, and then the base opposite my point. So this is going to be a pyramid, and that base has 6 sides, so it's also a hexagon. Bottom middle here, I have a lot of faces that are parallel to each other, but they're all the same shape, so it's going to give me the same base shape. But this is also a prism because I have 2 parallel faces, and the shape of those faces is a rectangle. Last one here on the right, I can see my apex, and then this right here is my base. So this is a pyramid, and the base shape is a triangle. Let's move on to surface area. Surface area is the sum of the area of the faces of a 3D shape. Looking at this pyramid right here, it asks us, how many faces does the following pyramid have? So we have our base right here, which is a rectangle, maybe a square, not sure. And then each of those sides of that shape pulls up to another face. So I have this one, this one here in the back, and this one here in the back. So that is a total of 5 faces, 4 on the sides and then my 1 base face. What shape are the faces? Well, my base is a rectangle, and then the ones on the side are triangles. To find the surface area of the shape, we will sum the area of all the faces. So I need to get the area of all 4 faces. So let's do that now. I'm going to start with my base right here, and that has an area of 7 times 7. So that is actually a square. So 7 times 7 equals 49. And then I need the area of my faces here on the side. Now, since they're all 7, so the base is 7 and this perpendicular height right here is 10. So that means that the area is going to be the same for all of them. So for one of them, it's going to be 7 times 10. And then I'm going to divide that by 2 because it's a triangle. And that gives me 35. So that's for one triangle. But I need 4. So it's going to be 35 times 4 to get the area of these 4 faces. And that's going to give me 140. So I need to add 49 plus 140. And that gives me 189 millimeters squared. Now we are going to find the surface area of this rectangular prism here at the bottom. So notice we have these faces right here that are the same and are perpendicular to each other. So if I look at those, I have an area of 8 times 4. So 8 times 4 is 32. And I have 2 of those, so it's going to be 32 plus 32. All right, so now let's do these faces here on the side, which is going to be this face, and then the face here on the back. So that area is going to be 20 times 4. And then I also have 2 of those. So 20 times 4 is 80. But since there are 2 of those, it's going to be another 80 plus 80. And then I have my top and my bottom. So I have this face right here. It's getting a little messy, I know. And then this face here on the bottom, which is going to be 20 times 8 for one of those. So we have 20 times 8, which is 160, and then I'm going to have 2 of those. So if I sum all of this up right here, that's going to give me 544, and then don't forget your units, millimeters squared. Now let's move on to volume. Remember that prisms have 2 bases. The bases are always parallel to each other and perpendicular to the height. Look at the triangular pyramid below, the shape of the base. So let's find the 2 faces that are parallel to each other. They're going to be right there. And so the shape of the base is a triangle. To find the volume of any prism, we will find the area of the base and multiply that by the distance between the 2 bases, or in other words, the height. Okay, so we're going to find the area of the base and multiply it by the distance between the bases, which is the same as the height. So to write that down, I'm going to write V equals, and I'm going to write a capital B, and the capital B represents the area of the base. The H represents the distance between the bases. Now, H can be thought of as height, although that may get confusing because, for example, on this one right here, the height would be this. And sometimes we think of height as a vertical distance, but it's not always. So it's just the distance between the bases right there. So looking down at this prism, we're going to find the volume of it. So it says calculate the volume of the triangular prism. So we need to find first the area of the base, which is going to be 2 times the perpendicular height, which I can see back here. So 2 times 1.5 feet. And then since it's a triangle, divided by 2. And that gives me 1.5. So that's the area of the base. And then the distance right here between the bases, or the height. So that's going to be 3.5. So I'm going to multiply 1.5 times 3.5. And I get 5.25 cubic feet. All right, let's look at this prism right here. It says this volume of this hexagonal prism, and it's calling it a hexagonal prism because this base right here, which we're going to mark in yellow, this base is parallel to this base, and the shape of the base is a hexagon. That's why we call it a hexagonal prism, based off the shape of the base. So it's telling me right here, it's telling me that the whole volume of this prism is 96 meters cubed. The distance between the 2 bases is 6. So it's telling me that this distance right here is 6. So now I got to figure out the area of the base. So using my formula that the volume equals the base times the height, let's substitute in what we know. So I can plug in the volume right here at 96. I don't know the area of the base. That's what I'm trying to figure out. But I know the height is 6. So 96 equals the base times 6. Divide both sides by 6. And I get that my area of the base is 96 divided by 6, which is 16 meters squared. Last section, we're going to talk about slicing. We are going to analyze the cross-section of a 3D shape when we slice it. The cross-section is two-dimensional. So think of a cross-section. If I take this cylinder and think of me cutting in half right here down the middle, so my knife is going to follow this path. The cross-section is if I opened it up and I looked at the shape inside, then that's the cross-section. If we slice this cylinder parallel to the base, the cross-section will be so my base for this cylinder is a circle because those are the two faces that are parallel to each other. So if I cut this shape parallel to the base, which would be right here, think of cutting it right there in the middle this way. What shape will the cross-section be? And it will be a circle. If we slice the same cylinder perpendicular to the base, so now I'm going to slice it vertically, think of me cutting it down, and I look at the inside shape. What shape will that be? It will be a rectangle. Okay, now let's look at this triangular prism right here. If we slice this triangular prism parallel to the base, the cross-section will be, okay, so here's my base. It's this triangle. If I slice it right here, down the middle like this, parallel to the bases, the cross-section will be a triangle. If we slice the same triangular prism perpendicular to the base, so now we're going to cut it perpendicular to the base, so like right here, cutting it that way, the cross-section will be a rectangle. Okay, down here at this bottom for this rectangular pyramid. If we slice this rectangular pyramid parallel to the base, so what is my base? Here's my apex, here's my base. So if I slice it parallel to the base, so right here, kind of like cutting it in half horizontally, the cross-section will be a rectangle or square, since we know that's a square, but we'll write a rectangle. If I slice the same rectangular pyramid perpendicular to the base, so I'm cutting it this way now, cutting it down in half, the cross-section will be a triangle. Notice that whenever I'm cutting parallel to the base, my cross-section will always be the same shape as the base. All right, let's now do some word problems with area and volume. These are just some key information that will help us solve the problem. Drawing and labeling a picture, writing down the information you know from the problem, and writing down needed formulas. Those three things are really helpful when dealing with word problems with geometry. Sandra needs to wrap a present that is in the shape of a pentagonal prism. The regular pentagonal base has an area of 25 square inches. The distance between the two bases is 10 inches. What other piece of information would you need to find the surface area of the present? So I have a pentagonal prism, which means that the base is a pentagon. I know that the area of the base is 25 square inches. And I know that the distance between the bases right here is 10. So it's asking me what would I need to know to find the total surface area of the present. I already know the area of these two bases. So if I need to sum them all up, I know those. I need to figure out the area of the sides here. The fact that it tells me it's a regular pentagonal prism tells me that all the sides of the pentagon are the same. And that's the piece of information I would need to know to figure out the surface area. Because to find the area of these rectangles, I need to know I know the length was 10, but I need to know this height. So I need to know the length of the side of the pentagon. Diego has a rectangular prism fish aquarium in his room that is 2 feet long, 1 foot wide, and 1 foot tall. What is the volume of his fish aquarium? I'm going to draw a quick picture of this, and then label it. So it's a rectangular prism. So I'm going to draw 2 rectangles, and then I'm going to connect each of the vertices, and that kind of gives me a visual. Now I didn't draw it to scale, I just drew one, and I'm just going to label it. But it tells me it's 2 feet long, 1 foot wide, and 1.5 foot tall. So now I need to find the volume. So the volume is going to be the area of the bases, which is right there. So 2 times 1.5, and then the distance between the bases, which is 1. So times all that together, and I get 3 cubic feet. Martha's 12-foot square garden will be surrounded by stepping stones that she will lay side by side. The stepping stones are 1 foot square. The shaded gray area in the picture will be stepping stones. How many stones will she need for her garden? All right, so I need to figure out the area of this shaded spot right here. I'm going to do that by finding the area of this big square and subtracting the area of this little square. And that's going to give me what's left. It tells me in the problem that it's 12 foot by 12 foot. So I know that this right here is 12 foot. So the area of the entire garden, like including the stepping stones, is going to be 15 squared, or 15 times 15. And then I need to minus 12 squared. So that's going to be 225 minus 144. And that gives me 81 feet squared. And that means I need a total of 81 tiles because each tile is 1 foot squared. Okay, that's it for today. Thank you.